Okay, hello, welcome to my channel. My name is Loanch, and in this video we're going to try to identify which of these relations are functions. All right, good. So the relations are given in this diagram form, like the mapping form, where we have this right here, which shows the first set, and then this is the second set. And here we haven't really specified which function, because it doesn't really matter what the rules are. All that matters is that all these. Okay, so you look at the second one, we also have some more examples. Good. Okay, so we want to use this definition of a function as a guideline, because we just want to identify which of these can represent functions, all right, in order to be able to have a better understanding of the definition. Okay, so a function f is a mathematical rule between a first set x and a second set y, in which every element in the first set corresponds to exactly one element in the second set. So to denote that relationship, we can write f of x equals to y, where x is an element of the first set and y is an element of the second set. And just to dive into the diagrams, okay, this is how we understand it. So this is the first set x, and then this is the second set y. So this this circle, no, not a circle, this shape is for the first set, this one is for the second set. Then this element x in here is an element of the first set, and this one is an element of the second set. So this arrow shows the correspondence based on the function f. Good. Okay, so we're going to use all of all those in looking at this thing right here. Okay, so let's start off with the first one to check whether this first one is a function. Okay, so we notice what we have: x1 corresponds to y1, x2 corresponds to y2, and then x3 also corresponds to y2. Well, I'm going to tell you that this right here is a function. Okay, so let me just put it down here that it is a function. And if you look at the definition, it says that is a mathematical rule between the first set x and the second set y, in which every element in the first set corresponds to exactly one element in the second set. So you look at x1, x2, and x3, they correspond to something. That is every element in the first set. So you look at the three elements here, they correspond. Okay, that is, they are assigned to something based on the function. So that is every condition is satisfied. Good. And then they correspond to exactly one. Look at x1 corresponds to y1 only, x2 corresponds to y2 only, and x3 corresponds to y2 only. That is, x1 doesn't correspond to y1 and y2. Like in one of our videos where we looked at temperature, we noticed that when it is 0 degree, we're going to have about, sorry, not 0 degree, when it is 0 o'clock, that is midnight, all right, we're going to have about 27 degrees. And when it is let's say around 23 o'clock, though we didn't really have the time, that time it will still be around that time, 27 degrees. So it was more like 27 degrees corresponds to more than one time. So that felt to be a function. But here, each of these, x1, x2, x3, correspond to one thing. Well, you might say, but y2 has two things coming from it, coming to it. Well, we don't care about the element in the second set, but rather the element in the first set must correspond to exactly one. Anyway, you're going to see an example where it breaks down. Good. So let's move to the next one. Okay, so for this second example, we have here that let me see. Okay, so for the second example, we have x1 corresponds to y3, x2 corresponds to y2, and y1 is left like that. So is this a function? Well, you consider the first condition is that every element in this first set must be mapped to something. All right. So x1 is assigned to something, sorry, y3 is assigned to x1, and y2 is assigned to x2. So every element here has something assigned to it. So that first condition is satisfied. Then the second condition is that every element in them must correspond to exactly one element in the second set. So x1 corresponds to y3 only, x2 corresponds to y2 only. So that means this is a function. Good. Well, you may say, but y1 is not assigned to anything. Well, like I said, we don't care about the element in the second set. This statement only tells us that in which every element in the first set corresponds to exactly one element in the second set. So every element in the first set must correspond to something, and each element shouldn't correspond to more than one in the second, but rather to exactly one in the second. So it doesn't matter whether every element in this second set has something coming into it. It doesn't matter. Okay, good. So this is also a function. Anyway, let's look at the third and the fourth. Okay, so for the third one, so you notice, is this a function? Maybe let me give a little time to do that. Well, this right here is not a function. Good. And I believe you've seen the reason. The reason is every element in the first set should correspond to an element at exactly one, but this one has failed to. This one doesn't have a corresponding. This one doesn't have a result. In other words, it's not a member of the domain. I'm not saying it's linked to that. Sorry, it's not what I'm trying to say. Maybe that would have been the game, but it doesn't. It's just like having this function. Let's say f of x equals to 1 over x, and let's say that this guy here x3. Let's say that x3 is the 0. So let me say x3. So x3 is the 0. So when you have 1 over 0, the result is not defined. So if this is a set of real numbers, we will not have a result here. In other words, this thing doesn't map to something. But a domain is, from our previous video, that is a set that contains every possible input. So if 0 is not a possible input, why should it be in the domain? In that case, such a set is not the domain. So yeah, this right here is not going to be the domain. And if it is the domain, then that's a relation. It's not a function. Good. So this right here is not a function. Okay, so let's look at the last one. So this last one, x1 maps to something, x2 also maps to something. Yeah. So every element in the first set corresponds to an element in the second set. But is it exactly one? Well, for x1 corresponds to only y1, so that works. But x2 corresponds to more than one thing. It corresponds to y2, it corresponds to y3. That means that is not a function, all right? Not a function. Isn't that very nice? Good. So that is it for the video. Just wanted to identify which of them is a function, which of them is not. Then we also have maybe other ways to classify functions based on other definitions, like one-to-one, which is an injective function, surjective, that's onto, and then bijective, which is both. We're going to look at that in the next video anyway. Okay, hope you enjoyed the video. Please don't forget to share this video with your friends, subscribe to my channel, and we'll continue from our next video.